We have a project for ESTCP where we're looking to further validate and demonstrate a passive sampler for PFAS. Traditionally, in environmental investigations, we tend to do active sampling. So this relies on collecting bulk media. For example, it's grabbing sediment, it's collecting bulk surface water or mechanically extracted pore water. And what this results in is a total concentration of the chemical that we're assessing. And this is not accurate for what different critters and environmental receptors are exposed to. So ultimately, it's an overestimation of the potential risk. Using active sampling methods for PFAS analysis can be really challenging because you have a lot of different materials and equipment that could potentially contain PFAS in them that might come in contact with your sample material. And that's something that we want to avoid to ensure that we're collecting samples that accurately represent the PFAS in the media that we're targeting. So passive sampling can offer a lot of advantages over traditional active sampling approaches. When we use passive sampling, we're able to measure what's called the freely dissolved concentration, or as C-free as we might call it. And this provides a more realistic measure of exposure for what our environmental receptors and our critters out in sediment and surface water are actually exposed to. Serum has been leading the way with developing passive samplers for different chemicals contaminants. And most recently, they've developed PFAS, which is a dialysis-based sampler specific for measuring PFAS. Dialysis-based samplers, which we also call peepers, are a very simple technique. It's a small plastic vial filled with ultra-pure water. It has a semi-permeable membrane that allows the freely dissolved concentration of PFAS to flow through it. By being able to measure the freely dissolved concentration, which is a more realistic measure of exposure for our aquatic organisms, it allows us to provide more realistic assumptions. It gives us better quality data, and we're able to conduct more accurate ecological and human health risk assessments because of it. And when we have more accurate risk assessments, that can help us determine the level of remediation that's appropriate and not potentially performing remediation when we might not have to.